Okay, in this video, we continue with probability distributions, and we'll continue with these discrete or distributions for categorical data. We're going to look at a very special type of distribution, though. It's the binomial distribution. And what makes the binomial unique is that we only have two outcomes. If we run a trial, we only have two outcomes. Like flipping a coin is a binomial experiment, or binomial follows a binomial distribution because there's only two outcomes. The trick is, what if we flip that coin a whole bunch of times and we want to calculate probabilities of maybe getting 3 out of 10 or more than 3, those type of things. But it's beyond just flipping a coin. Certainly that's the common example, but we can extend this, and it can represent anything where there's two outcomes. Think about on and off, success or failure. Getting cancer or not, being approved for a loan, defaulting on a loan. All of these are binomial experiments because there's two outcomes, and we can use the binomial distribution to calculate these probabilities. Now we're going to do this in Excel. Keep in mind that when we use the binomial distribution and we're running different trials or successive trials, that these trials are independent, where one outcome doesn't influence the other. And that sometimes is an assumption that maybe not be true. But let's go to Excel and let's solve a problem. In Excel, this is the formula that you use, the binom.dist. It has 4 arguments. One of them is called the number S. Trials is the second one. Probability S is the third one, and the cumulative is the fourth. So what the number this number S is the number of successes, and the next argument is out of how many. So how you want to read this is that how many successes out of how many of this trials. So the trials is always greater than or equal to the number of successes. The probability S is this is an input, the probability of success for one trial. So like flip a coin, that number is 0.5 if you would define success of getting a heads, for example. And then cumulative is a flag variable. It takes on a value of either 0 or 1. I think you can use true or false. And it represents, do you want the exact probability or the cumulative probability? So with this formula, and there's other ways to have done it. You can use a calculator. There's a complicated formula if you want to do it by hand. But Excel lets us do it really quickly using this formula. Let's solve a problem. And it's a somewhat trivial problem, but let's solve it anyway. We've got a basketball player who shoots 10 free throws. So let's say every game he shoots 10 free throws. And we know from historical information that his probability of making one free throw is 62. Or the other way to say it is that his free throw percentage historically is 62%. So what's the probability he's going to make exactly 6? Well, let's use the formula. And let's put in 6 out of 10, where the probability is 0.62, and we're looking for exactly that, so we want to use 0 as my last argument, not 1. 1 is for cumulative. So the chances of making it is about 24% or 25%, close to that. What about making 6 or less? So the probability of making 0 plus the probability of making 1, all the way up, adding to the probability of making 6. Same thing. Put in 6 out of 10, 0.62. The last argument, though, is 1, not 0. And you can see it has to be greater than or equal to the exact, because it includes that one plus anything less than that. Well, the next one is the probability that x is greater than or equal to 6. And you could solve this by calculating the probability that x is equal to 7 plus the probability that x is equal to 8 all the way to 10. But that's a little bit unwieldy. The better way to think of it is that when you get a right-hand side or a greater than, we can replace that with 1 minus the probability that x is less than or equal to 6. Much better way to do this, because we just calculated the x less than or equal to, because that's what the cumulative distribution is. So to calculate the probability of the right-hand side or greater than 6, it's just 1 minus the probability that x is less than or equal to 6. So this is just 1 minus the number we just calculated. What's the probability that he shoots 10 free throws in a game and doesn't make any? 0 out of 10, 0.62 success for one shot, and 0 is find the exact probability. That's a really, really, really small number. The likelihood that he would never go and a game and not make and shoot 10 free throws and not make any is really unlikely. But what's the chance he's going to make all 10? Zero out of 10, 0.62. Last argument is 0, and this is 10. 10 out of 10. And it looks like it's less than 1%, almost 1%. So maybe if he played 100 games, which I don't think they play 100 games in an NBA season, but if he plays 100 games, the chances that he would be able to make all the free throws that night if he averaged 10 is he would do it maybe 1 out of 100 or so. Okay, let me show you one other thing. Let's list all of the outcomes of X, 0, 1, 2, 3. Let's list these all the way out to 10. Here are all the possibilities. If you shoot 10 free throws, you can make none, you can make 1. Let's calculate the exact probability. Now, I'm going to add some arguments up here. This is probability of success is 0.62. These are going to be my trials, 10. And given that, I'm going to write binom.dist. Probability of this many successes out of these trials. This is my probability, and I'm going to find exact probabilities. Now these last two arguments, I'm going to put dollar signs around it because I'm going to copy this down and I want to hard code those cell references. The reference, say H11, I want it to float or be relative. So when I copy this down, there you go. There's the distribution. You could certainly plot that if you wanted to plot that in like a scatter plot. Something like that. I don't know if you would really want to draw the lines. I don't think the lines help because you can't get anything in between. But there you go. You can see an indicator of what these dots tell you. The probability that X is equal to that. I can also do the cumulative probability, and I can do it two ways, but let's do it using the distribution first. X is less than or equal to X, so this is the cumulative. And the same thing, binom.dist. These are my successes out of this many. This is the probability of 1, but now I'm going to use 1. And again, hard code these references. Copy that down. And if you plot let's plot all of them just to show you what it looks like. So the blue is the individual probabilities, and then you can see the red, the cumulative, it just keeps adding to. It's called a non-decreasing function because you're always adding something to what the previous number was. And you see it always tails off at 1 because that's when it maxes out. Okay, that's enough information on the binomial distribution. We'll continue with another one in the next video. Thanks.